In this video, I'm going to go over a few of the different points about acceleration that are important. Some of the different types of acceleration, namely positive acceleration, negative acceleration, and then deceleration, so on. And finally, we're going to talk about the difference between deceleration and negative acceleration. These two are very easy to confuse, but I will show you very clearly the difference between the two. So here, you've got a plane that is decelerating, which the definition of decelerating is slowing down. Now notice that slowing down is a term of speed. It's a decrease in speed. It has nothing to do with direction. Therefore, we can't equate that with our variable or our vector of acceleration. Here's another subway train that is decelerating. Now, one of the important things to note about deceleration, the only thing that deceleration means, or slowing down, is that the acceleration is in the opposite direction of the velocity, causing the speed to decrease. Let me show you a little clearer how this works. Here I've got four situations. I have a car that is driving along, but in each case I've got something happening that's a little different. For example, with car A, you have a car that's moving in the positive x direction, and it is speeding up. So the velocity is to the right, and the acceleration is to the right. Okay, so what's going to happen? Let's say that we have a starting velocity of 10 meters per second and a final velocity of 20 meters per second, so we've sped up. So my acceleration is change in velocity over change in time. Change in always means final minus initial. So I went from 10 to 20 meters per second. So final is 20, initial is 10. Therefore, my acceleration is, my change in velocity is 20 meters per second minus 10 meters per second. If I do that in a time of 5 seconds, then I get 20 minus 10 over 5, which gives me a positive 2 meters per second squared acceleration. In car B, you have the car again moving in the positive x direction, but this time it's slowing down. Let's say it's going 20 meters per second and slowing down to 10 meters per second. Therefore, the acceleration is pointing to the left, and I'll show you why. So our final velocity is 10 meters per second. Our initial velocity is 20. So we're going for so we're starting at 20 meters per second, slowing down to 10 meters per second. We get 10 minus 20, which gives us negative 10 over 5, or a negative 2 meters per second squared. That's why the acceleration is pointing in the negative direction. It's because you have a negative change in velocity. Car C is moving to the left, but also slowing down. So again, you have this car moving at 20 meters per second. It slows down to 10 meters per second in the negative direction. So we have the exact same equation as we have in part B, except that now our velocities are negative. We're starting at 20 meters per second to the left, so negative 20 meters per second. And we're slowing down to 10 meters per second to the left, so negative 10 meters per second. So we've got a bunch of extra negatives here, so you end up with negative 10 plus 20 over 5, which gives you a positive 10 over 5, or positive 2 meters per second squared. So we're still slowing down, decelerating, but in this case we have a positive acceleration. In the final case, car D, you're moving in the negative direction, so you have negative velocities. But in this case, you're speeding up. So you start off at a negative 10 meters per second, but you speed up to a negative 20 meters per second. So our final is negative 20, initial velocity is negative 10. And so we get a negative 20 plus 10 would give us a negative 10 over 5. That's a negative 2 meters per second squared. So in A and D, you are speeding up, but in B and C, you're actually slowing down, or decelerating in both B and C. So B, you have a deceleration and a negative acceleration. But C, you have a deceleration but a positive acceleration. D, you have you're speeding up, so accelerating, but you have a negative acceleration to do that. Here's the point. If a car is speeding up, like it was in parts A and D, then the acceleration is in the same direction as the velocity. If the car is slowing down or decelerating, then the acceleration is in the opposite direction of the velocity. That was the case in both B and C. A deceleration is merely a decrease in speed. We don't care about direction. But a negative acceleration is a change in velocity in the negative direction. Deceleration happened in both B and C, but negative acceleration happened in B and D.